Hi there, here is your teacher Neha and welcome to my channel. You are watching all about chemistry. In today's video, I will explain the types of hybridization. So before starting, please subscribe my channel and press the bell icon so that you get the necessary notification for the upcoming videos. Now, in the previous video, I have explained what is hybridization, from where the concept comes from. Okay, so there may be a question that since the hybridization is occurring between the orbitals which is differing in slightly different amount of energy. Okay, they are differing by very less amount of energy with each other. So from where, and also the hybridization, the mixing of orbital needs energy. Okay, it requires energy. So from where this energy comes from? For mixing of orbital, for hybridization, from where this energy the orbitals are getting? Now you must note that the energy required for excitation of electrons becomes available when the combining atoms approach each other. Only when they approach each other, not in the isolated state. When the atoms will approach each other, this energy becomes available because the energy is released when the combining atom approach each other. Understood? This is why hybridization never takes place in the isolated atoms but occurs only when at the time of bond formation. Okay, this is how they are getting energy to hybridize. Now let us have a look on the types of hybridization. So the first one is Sp hybridization. As the name suggests clearly, you can see that here S and P orbital is hybridizing. Now how many S and how many P orbital is hybridizing here? Only one S and one P. So you know that there is S and there are 3 P orbitals. Okay, so this one S is hybridizing with one P orbital and leads to Sp hybridization. Okay, in the terms of orbital diagram, you can show like this. This is S, this is, suppose it is 2S, this is 2P X. There are other orbitals also. This is 2P Y and there is one more orbital, that is 2P Z. These are the hybridizing orbitals. So 2S will hybridize with 2px only and 2py and 2pz will remain as such. In this case, the hybridization is called the Sp hybridization and the orbitals thus formed is known as Sp hybrid orbitals. Okay, now you know that the total number of hybrid orbitals is equal to the total number of atomic orbitals that are hybridized. Okay, so here 2 orbitals are mixing, so the total number of orbitals, hybrid orbitals formed will be 2. The orientation of these orbitals is such that they will experience minimum amount of repulsion. So the shape of the hybrid orbitals is like this and they will together oriented like this. These are 2 hybrid orbital, Sp orbitals. Okay, this is the internuclear axis and the bond angle between and the angle between these two hybrid orbitals will be equal to 180 degree. Okay, they are collinear. They are collinear with the angle of 180 degree as shown here. Now each of the orbitals sp, each of the hybrid orbitals thus formed will have 50% of s character and 50% of p character. The remaining two orbitals pxy and pz, 2py and 2pz will not take part in hybridization and will remain as such. And if these are half filled, they may form bond with the other atoms having half filled atomic orbitals. Okay, they may form bond. The examples of the compound which shows sp hybridization are BeF2, beryllium fluoride, or beryllium hydride, etc. All the compounds of carbon that are containing carbon-carbon triple bond are sp hybridized orbital. The carbon is here is containing sp hybrid orbitals. Okay, so this is the first type of hybridization. The next type of hybridization is Sp2 hybridization. As the name is Sp2, here 1s is hybridizing with 2p orbitals. Orbital diagram of Sp2 can be made like this. 1s is mixing with 2p orbitals. Now the 3 orbitals are mixing, so they will generate 3 hybrid orbitals, and they will be oriented in such a way that they will experience minimum repulsion between them. So the orientation will be like trigonal planar arrangement. This is the orientation. 3 sp2 hybrid orbital, and the angle between the orbitals will be 120 degree. Okay, now the hybrid orbitals thus formed have 1/3 s character, that is 33% s character, and about 67%, that means 2/3 of p character. Okay, the non-participating p orbital, if half filled, it can form bond with the other atoms having half filled orbitals. The example of this type of hybridization can be seen in boron fluoride. Okay, and the carbon compounds that contain carbon-carbon double bond. Here carbon is sp2 hybridized. Now the third one is sp3 hybridization. Here 1s is combining with 3 p orbitals. Okay, all the s and p orbitals are intermixing to generate 4 sp3 hybrid orbitals. So the 4 orbitals generated, that is 4 sp3 hybrid orbitals generated, will oriented as a regular tetrahedron. Okay, they will show the tetrahedral geometry, and the angle between these orbitals will be 109 degree 28 minutes. Okay, now the orbitals here will show 25% of s character and 75% of p character. The examples of the compounds that show sp3 hybrid orbitals are the carbon compounds where carbon is connected to another carbon with a single bond, or carbon-carbon single bond containing compounds, and also CH4 and C2H6 etc. C2H6 etc. These are the examples of compound. It is very interesting here to mention that the size of the sp orbital is smaller than that of the sp2, which in turn is smaller than that of the sp3 hybrid orbitals. Okay. Now since the orbitals is orientation in certain direction, that's why they have directional characteristics, and this decides the shape of the molecules. Okay, so there are some other hybridization also which involves d orbitals, but we will discuss in some next video. That's all for today. Thank you.